Hi, this is Fazana again. Welcome to part 6 of this topic of straight line graphs. Please watch parts 1 and 5 before watching this to ensure that you take all the necessary steps to rise from the basics to the top. In this video, we'll cover the so higher level questions. Once you've worked through these, you'll have the knowledge and confidence to handle any straight line question. Let's begin. Okay, so let's just recap. We now know the equation of a straight line is y equals mx plus c, where m is the gradient, which measures the steepness of the line. And the way to calculate the gradient is you go change in y divided by the change in x. So if you have a straight line, you just draw your triangle. You see what your change in y is divided by your change in x, or if you have two coordinates, your x and y, then you're doing the change in y divided by your change in x. Okay, so we've been through that here. And the c is your y-intercept, so where the line actually crosses the y-axis. Okay, yeah, all right, okay. Let's get on to the questions now. Okay, if you were asked to solve the simultaneous equations with a graph, and we've done simultaneous equations, so I've done videos on simultaneous equations, the linear ones, because these involve straight lines. So have a look at that, and we solve it algebraically. But here we're actually going to use the graph to solve it. Okay, so all you need to do is it makes it much easier to rearrange it so you've got y the subject. So you can tell you're going to minus x from both sides. So you have y equals minus x plus 5. And always try and write it in the form of mx plus c. So you can tell your gradient here is minus 1. Yeah, all right. Okay, and here you're taking your 2x to the other side, so you're minusing 2x, so you've got y equals minus 2x plus 6. Okay, do you remember when I showed you how to plot a straight line graph using the nth term, because the nth term is an plus c, where a is your difference in your numbers, so that would be the same as the m, and your c was your 0th term, which is the same as your y-intercept. Okay, so I'll show you how to use the nth term to plot if you haven't seen that video. So your 0th term would be the 5, so you start with 5 there, and then you say what's your difference in your numbers? Minus 1, so you go minus 1, which is 4, and minus 1, which is 3. And then, of course, when you're going that way, you're going plus 1. So you've got 6 and 7. Okay, that was easy, wasn't it? Here, your 0th term is 6. And then your difference between your numbers is minus 2. So you're going minus 2 that way and plus 2 that way. So you've got 4 and 2. And adding 2, you've got 8 and 10. All right, okay. So then you sketch it. And simultaneous equations, solving it by either algebraically or graphically, all you're trying to find is the point of intersection. All right? Sorry, I forgot to show you something on the other slide. When we plotted the graphs, can you see we had 1, 4 there, and we also had 1, 4 there. So that is the point of intersection between the two lines. Okay, so that coordinate there is, you can tell, 1, 4. Yeah, all right, easy, wasn't it? Okay, let's find the point of intersection between the following pair of lines. So this time we're not actually going to sketch it. We're just going to solve it algebraically. This one's really easy. You know, when we normally doing simultaneous equations, the linear, we always have something like, 2x plus 3y equals 12, and then 3x minus 3y equals 8, let's say, and then we have to eliminate one of these, and then in this case we'd actually add, and then that would be eliminated, yeah, and then you'd have 5x equals 20 or something, okay? So it's always in the form of something x plus something y equals a number, okay? And then when you find your x, you go in and substitute it in there and then go find your y, okay? But this one's really easy. If you can rearrange it as y equals that and y equals that, then remember when in the previous question we had that point of intersection of 1, 4, you can tell that 4 was the y coordinate on both the lines. So if y is that and y is that, then you've actually eliminated the y, yeah? And you can say, well, 5x minus 8 is equal to 1 minus 4x, because that x coordinate of 1 was the same for both, yeah? All right? So then it becomes a really nice linear equation. Always pick your lowest letter. So you've got minus 4x, so we'll do the opposite. So we've got plus 4x, so we've got 9x minus 8 equals 1. And then we're going to add the 8, and we've got 9x equals 1 plus 8 is 9, and then divide by 9, and we've got x equals 1. Okay? And then we go stick it in there to find what our y is. So y will be 5x, so 5 times 1 is 5 minus 8, which is minus 3. Okay, so you can tell your point of intersection is 1 minus 3. Yeah, all right, point of intersection. Before I actually write that on my answer sheet, I'm just going to test it in here, because I want that guaranteed 3 marks. Yeah, so y was minus 3, and you've got 1, and then you've got minus, just put the minus first, and then 4 times 1 is 4, so 1 minus 4 is minus 3. Yeah, and you can see that works, and you tick and say, God, I'm good. Yeah, all right. If you're still not too happy with simultaneous equations, please watch my videos, and there are quite a few examples, so you get it by then. Yeah, all right. Okay, let's get on to some higher ones now. So you've got points A and B and C have coordinates of those, and show that triangle ABC is right angle. Now there are 2 methods of verifying a right angle triangle. So I'll just draw a triangle here. Okay, so if it's on a coordinate, you've got to find the gradients making up the 3 sides. Yeah, and you know that when lines are perpendicular, yeah, then the product of the gradients will be -1. So let's say that gradient is m1 and that gradient is m2. So m1 times m2 will be -1. Yeah, and that shows that those 2 lines must be perpendicular for there to be a right angle. Okay, so that's one way to show that it's a right angle triangle. And then the other way of showing that it's a right angle triangle is we used the Pythagorean triple. So if that was 3 and that was 4 and that was 5, yeah, centimeters, then if you know using Pythagoras, then 9 plus 16 would be equal to 25. Yeah, because we've proved that a squared plus b squared equals c squared. Okay, so that's another way of proving the triangle is right angle. Okay, but let's try, I've sketched it, so let's try doing it. Okay, all right, so let's try the first way. This looks like that's the right angle triangle. Okay, so we're going to find the gradient of that, and then we'll find the gradient of that, and they should multiply to give -1. Okay, so the product of gradients would be -1. Okay, so if we're trying to find the gradient of that line, then our change in y, yeah, so it's going from 0 to 3, and then the change in x is from 5 to 7 is 2. But can you see, because we're drawing our triangle that way, it'll be minus there. Okay, so your m1 is your change in y, which is 3 divided by -2, and you know it's going to be a minus, and then 3 halves make 1.5. Yeah, and then our gradient for that line there, I've just pre-drawn the triangle. So from 4 to 7 is 3, and then from -2 to 0 is 2. Okay, so then your change of y is 2 divided by 3, so that's 2/3. Okay, I'll forget about the -1.5 because it's easier to do that. So when we're going m1 times m2, we have 3 minus 3 over 2 times 2/3, and we should be getting -1, so we know it's a minus. And then of course when we cross divide, this is so soothing, you can tell you get -1. Okay, so you've proved that that's a right angle triangle. Okay, the other way of course is to find the lengths of them. So again, we can find the lengths of them because every time we draw this triangle, we get a right angle triangle. Okay, so if we want to find the length of that, sorry, the letters aren't very, so let's just put the letters there. That's A, that's B, and that's C. So the length of AB equals the square root of 3 squared plus 2 squared, which is 9 plus 4 is 13. Okay. And then we'll take BC, because let's just do BC. Oh, we have done BC, sorry. Because, sorry, AB is the same. So can you see AB would be the same as 2 and 3, and that's 2 and 3. Yeah, so you can tell BC is the same. So that would be the square root of, again, 2 squared plus 3 squared. You can actually ignore the negatives, because when we square it, it'll become a positive. So that will be 13. And now let's find the length of AC. So here we've done the triangle, so that's your right angle triangle. So from 4 to 5 is 1, and from -2 to 3 is 5. Okay, okay, so AC will be the square root of 1 squared plus 5 squared, which will be the square root of 26. Okay, yeah, and you can tell, sorry, I don't have much space here, so we'll just do it here. Yeah, so you can see if you said surd 13 squared plus surd 13 squared should be equal to surd 26 squared. And you can tell that works because 13 plus 13 equals 26. Okay, all right. So these are the two ways of showing that you've got a right angle triangle. All right, okay, that was easy. Okay, don't know what all that is. All right. Okay, those 3 points, C is 4K, are the vertices of a right angle triangle ABC, so that's your right angle. Find an equation that passes through AC. So again, you know these two lines are perpendicular. Yeah, so we're going to have to find the gradient of that line, which we can, and then we know that line will have the negative reciprocal. Yeah, so find the reciprocal, change the sign. Okay, so let's find the length of this line. So again, you could draw your triangle, but after a while you'll find you'll be able to do it with the coordinates themselves. So from -2 to 6 is 8, and from 1 to 5 is 4. Okay, so your gradient of AB equals change in y, 4, divided by change in x is 8, so that's a half. Okay, so your m equals a half there. So what's the reciprocal of a half? 2. So your gradient of BC will be 2, and then you change the sign. Okay, because you know a half times -2 will give you -1. Okay, so we know that m here is -2. All right, okay, we'll use that and try and find the equation. So the equation of BC we know the first part of it, so y equals -2x, and we know a point that lies on the line, so we actually go and substitute it. Yeah, so instead of putting y, we'll put the 5, and then we'll go minus, and then 2 times the x coordinate is -12, and what you do to -12 to get 5, you'll add 17. Yeah, so that means the equation of BC is y equals -2x plus 17. All right, yeah. Okay, now if we go substitute that in there, we'll be able to find what our k is, which is the y coordinate. Yeah, so here we're going k instead of putting y, so now we're substituting that in, which minus, and then 2 times your x coordinates, so 2 times 4 is 8, plus 17, and 17 minus 8 is 9, so that means k equals 9. Okay, so then you can tell that's your coordinate there, so 4, 9. Okay, and then once you've got that, you can find the equation of AC. And again, don't do this in exams, always just do it from top to bottom. I tend to just run out of space with my Wacom here. Okay, so we did that one first, that one second, and then that one third. Okay, so again, the equation of that line, let's find the gradient, and you've got m equals your change in y. So how much did it go from 1 to 9, which was 8, divided by how much did it go from your x, -2 to 4, which is 6. Okay, so that would be 4/3. I'll just leave it like that for the moment, and then we'll convert it into a mixed number. So we've got y equals 4/3 x. And anytime you're finding the gradient, you know that if a line is going that way, it's got a positive gradient, and if it's going that way, it's got a negative gradient. Yes, always just check, so you know that one would have the negative, yeah, and this one has the positive, so then you know you've got the sign right. Okay, and now we can substitute the -2, 1 in there, all right, rather than the 4, 9, which is something we've got. So we're going to stick that in there. So we're going to do 1 equals, and we know we're going to get a minus, and then you've got 4 times -2 is -8, thirds. And then what do you add? Okay, so here you know you've got minus 2 and 2/3. And what do you do to minus 2 and 2/3 to get 1? So you know you have to add 3 and 2/3. Okay, so then you know your equation is actually y equals 4/3 x, so now we'll put 1 and 1/3 x plus 3 and 2/3. All right, okay, so every time you don't know what the c is, remember, substitute and whatever comes out there, yeah, so you can tell 1 equals minus 2 and 2/3 plus 3 and 2/3. All right, okay. So I said, if you found that difficult, just rewind a bit, pause, try doing it yourself, and then again, just go through the workings. All right, you try it twice, at the most 3 times, and you find that in exams, the questions will be so similar that you'll know the questions and the numbers so intimately that you'll remember what you need to do next. Okay? All right. Okay, this question is becoming very popular in the 9-to-1 board of exams. Yeah, so diagram shows a circle of radius 5 centimeters center the origin. Find the equation of the tangent to the circle, and you know radius meets tangent at 90 degrees. Yeah? Okay, so it's a really easy question. It's just because when they talk about a circle and then you suddenly think, oh, what is this? All you need to know is that perpendicular fact. Yeah? And once you've got that, then again, just keep it simple. All right? So you know the gradient of the radius and the gradient of the tangent, if you multiply them, so the product of those gradients will be -1. Okay, so let's start finding the gradient of the radius. Okay, and again, if you need to draw your triangle, you've got 3 there and 4 there. Okay, and you should know this Pythagorean triple, 3, 4, 5. Yeah, so if we needed to find the radius, which we've been told, oh look, we've confirmed it, 3, 4, 5. Yeah, so your change in y is 4 and your change in x is 3. Oh, we have another 4/3. Yeah, so you know the gradient of your tangent will be the reciprocal of 4/3, which is 3/4, so you're just really turning it upside down. Yeah, and then you change the sign. Okay, so then the equation of the gradient, you know it starts off with y equals minus 3/4 x, and then we don't know our c, so we just substitute that point in there. So we're going 4 equals, and now you're going minus 3/4 times 3, so you know times 3, so you know the minus, and then on the side here you go, oh, 3/4 times 3 equals 9/4, which is 2¼ Yeah, all right. Never do your workings in there because it becomes so jumbled you can't actually see the simple picture. Yeah, you suddenly don't have no clue of what you're doing and what to do next. Okay, so all your workings on the side. So you've got minus 2¼ and what do you do to minus 2¼ to get 4? We have to add something bigger, so we'll add 6¼ Yeah, all right, so that goes in there. So the equation of the tangent to the circle at 3, 4 is y equals minus 3/4 x plus 6¼ And again, I always told you to check. You've got this minus 3/4, which seems to make sense because you know when a line is drawn that way, it's always got a negative gradient. All right, cool. That's all for now. Please go through these questions carefully so when you see something similar in your exam paper, that smile will appear. Your mouth will go from a straight line to a great looking curve. Ha ha ha. Keep working hard, practice, practice. And remember, you're in control. Take care. Until next time. Bye.